Alright, y'all, 6.3, simplifying radicals. Alright, so remember these rules. The square root of a product is equal to a product of each square roots of the factors. And if I got two things that are being multiplied under separate radicals, I can combine them and put them under a single radical. You know, that works the same with our division, right? The square root of a divided by b equals the square root of a divided by the square root of b. And then once again, if they're separate, I can combine them into one radical with my top being divided by my bottom. Alright, so we're going to be simplifying in this section. And to simplify, it's nice if you would learn these perfect squares. Because to simplify, we want to have numbers that have square roots in the future. Okay, so number one, I got to simplify the square root of 90. So I'm looking over here for factors of 90 that might be in my perfect squares. Alright, there's a 9. So is that the largest factor of 90? It looks like it's the largest factor. So I'd make that a square root of 9 and a square root of 10. Because 9 times 10 is 90. Now, the reason we wanted a perfect square as one of our factors is because now what's the square root of 9? The square root of 9 is 3, so that gives me a 3. We cannot do nothing with the 10 because it has no factors that are perfect squares, so the 10 has to stay under the radical. And then that would be our final answer. Now, old school, what I was talking about is you can break that 90 down into factor tree. Make that a 9 and a 10. Make the 9 a 3 and a 3. Make the 10 a 2 and a 5. So technically, you would have under your radical a square root of 3 times 3 times 2 times 5. Because those are all the factors of 90. Now, for every pair of factors under here that match, they come out as a single factor. So what I mean is, right here is a 3 and a 3. Those match. But 3 times 3 is 9, and the square root of 9 is 3. Now I'm going to draw the radical because the 2 don't have a matching set, and the 5 don't have a match. So since they don't have no matches, they get multiplied and stay underneath. So either way you go, you're going to get 3 square root of 10. Alright, number 2, same thing. Square root of 150. Alright, so let's see what factors up here might be perfect squares. So I know 25 goes into 150, and that looks like the largest one. So I'm going to make that a 25. And then let's see, if you don't know the answer on that, we take 150, divide by 25. That means a 6 goes under the other radical. Alright, so 25 times 6 is 150. But y'all, what's the square root of 25? The square root of 25 is 5, so that's going to give me 5. There's no factors up here that are going to have a square root to help me out on the 6, so the 6 has to stay. And y'all, that's another thing. Although 1's a perfect square, it don't help me bringing it out because I still have 6 and 1. And square root of 1 is 1, so that's not changing our answer any by bringing out that 1. Alright, now watch this. 150 we could have broke into the factor tree. 150 could be, we know, 25 and 6. 25 can be 5 and 5. 6 can be 2 and 3. So that under your radical would be 5 times 2 times 3. So once again, a pair of 5s would come out as a single 5. And then since the 2 and 3 didn't have nothing to pair up, we'll multiply them back together and keep them under the radical. Alright, square root of 20. Alright, so let's see what factor over here goes into 20, and there's only a few I can choose. So how about 4? So I'll make that a square root of 4, and then 4 times 5 is 20. Alright, so now what's the square root of 4? That's 2. Can't do nothing with that square root of 5, so it stays under the radical. Let's see, square root of 12. Alright, so let's see. Once again, the only factor I see is a 4, so I'm going to make that a 4 and a 3. So 4 times 3 is still 12, but now square root of 4 is 2, so I get 2 square root of 3. So see what I'm doing? One of the numbers has to be out of this list if it's going to have anything that I can simplify, okay? Alright, 5 square root 600 x to the 4th. Alright, so I don't have to do nothing special since this is an even exponent. But after a while, if we get odd number exponents, I'm going to have to show you a trick. Because right now, even exponents will all divide nicely by that index of 2. So let's play with the 600. What's the largest factor up here? So I know 25 will go into 600, but I'm looking and look at that. There's a 100 sitting there. And 100 is the largest factor, so I'm going to have to pick it. So watch what I'm going to do. I'm going to make two radicals. 100 is going over here, and then the 6 goes into that radical. Now, since that's an even exponent, put all the x's in the first radical. Now watch this. What's the square root of 100? That's 10. Now remember, on the variables, I'm going to write my variable, and I'm going to divide its exponent by the index, which is a 2. 4 divided by 2 makes that an exponent of a 2. Now, I can't do nothing with that 6, so I bring down that radical, and then put my 6 in it. And then that would be our final answer. Alright, y'all, 6 looks about the same. Let me see. Looks like a square root 80 a squared b. So this time the b don't have an exponent, so it's going to be like a 1. So let's look up here for factors that might go into my 80. Okay, 4 go into 80, I'm sure. Anytime a 4 goes into 80, let's check 16. So 80 divided by 16 gives me a 5, so 16 goes into 80. And then, y'all, I don't see nothing else, so I'm going to use 16 and 5. Okay. The 2 is an even exponent, so that means it'll divide by the index, which is a 2. So I'm going to bring down my a squared and put that with the 16. Now, since b is an odd exponent, you have to put at least 1 into the right side. So since I'm putting 1b in there, there's no b's left. Alright, so let's see what we got. Square root of 16 is 4. Square root of a squared, 2 divided by 2 is 1, so that comes out as a single a. Then I write my radical and my 5b. So, final answer. Now remember, since there's only one b, there's not enough to divide by 2 and come out. Alright, so we'll have some more of those odd exponents coming up, and that'll be able to show you what we got going on. Alright, let's see, number 7. Multiply and then simplify. So a square root of 2 times a square root of 6. So remember, the first thing they want me to do is multiply the numbers and keep them under the radical. So 2 times 6 is 12. Now remember, my perfect squares from earlier, I need to find a factor of 12. That's a perfect square, which would be a 4. And then 3 would go under the other radical because 4 times 3 is 12. Remember, my perfect squares are 1, 4, 9, 16, 25, 36, 49, and so on. Usually you're going to pick a 4, a 9, a 16, or a 25 in the most cases, okay? Alright, square root of 4 is what? 2. Can't do nothing with the 3, so it stays under its radical. Alright, square root of 10 times the square root of 6. So remember, first thing I want to do is multiply them and keep that under the radical. So 10 times 6 is 60. Alright, let's think of a factor that might be a factor of 60. So let's see, 4 times 15 is 60, so it's a factor. and then nothing else is a factor of 60, so the only one I can use is the 4. So we'll make that a 4. And then remember, 60 divided by 4 is 15. Now, what's the square root of 4? That's 2. Can't do nothing with the 15, so put it under its radical. And y'all remember, you could be using factor trees. 60 breaks into 30 and 2. 30 is 15 and 2. 15 is 3 and 5. There's a pair of 2's that comes out as the single 2. The 3 and 5 don't have no pairs, so they multiply and go under the radical. Alright, number 9. Square root of 5x times square root of 15x. So we're going to multiply everything and keep it under the radical. So 5 times 15 is 75. X times x is 1 plus 1 gives me a x squared. Alright, let's see. I've got to simplify. So the 75 have a factor up here, and y'all look at that. 25 is a factor of 75, so I'm going to make that a square root of 25. And then over here is a square root of 3, because 3 times 25 is 75. Now, also, since that's an even exponent, we put all of them into the first radical. Alright, let's see what we got. Square root of 25 is 5. Square root of x squared. 2 divided by 2 is 1, so that comes out as an x. Cannot do nothing with the square root of 3, so keep it under its radical. Alright, y'all, here we go with some good exponents. 3b7 times square root of 6c8. So first, let's make the big radical. 3 times 6 is 18. I don't have b's in each radical, so that'll just bring down to b7. And then I don't have c's to multiply in each radical, so I'll just bring down to c8. Now, 18 I'm going to break into 2 radicals. Now, the largest perfect square up here would be 9, so I'm going to make that a 9 and a 2. Now, watch what I do with the b's. Remember, if the exponent is odd like the 7, you got to put one of the b's over here, and then the rest into the first radical. Well, 7 minus that 1 would leave you 6 b's, because now 6 will divide by the 2, and then will come out perfect. Now, since the 8 is an even number, we put all 8 of the c's in the first radical. So watch what I do. Square root of 9 is 3. 6 divided by 2 is 3, so that leaves me a b3. 8 divided by 2 is 4, so that leaves me a c4. We couldn't do anything else with what's under the radical, so that comes down as a square root of 2b. And remember, at this point, I don't even need to write the 1. Alright, y'all, they want me to divide and simplify, so a square root of 20 divided by a square root of 5. That's like a square root of 20 divided by 5, which is what? Square root of 4, and the square root of 4 is 2. So they're just going back to the other principle we learned earlier. Here's what? A square root of 15a divided by a square root of 5a. So remember, I can write that as a single fraction, 15a on top, 5a on the bottom, because now look what happens. Those a's cancel, so I have a square root of 15 divided by 5, which is 3. And y'all, since 3 is not a perfect square, I can't simplify it and go no further. Alright, plenty of time for this last one. 13 on top is a square root of 35 x y to the third. On bottom is a square root of 7x. So let's write that as a single radical. 35 x y 3 on top, 7x on the bottom. Alright, so let's see what's going to be in the radical after we divide. 35 divided by 7 is 5. The x's cancel, and then I got a y3 that has no y to divide by, so it stays on top. Alright, so the 5 I can't break down any, so I know it's going to stay under the radical. But y'all, I do have 3 y's in there, and remember, the y's can be split up so that I have the 5 over here. Remember, 1 y has to go over here, which means 2 y's go in the first one. You can never have more than one of a variable under a radical when you're done. Alright, let's see what happens. 2 divided by 2 is 1, so that comes out as 1y. Square root of, can't do nothing with that 5 and y, so they stay under the radical. Alright, y'all, so you got to get used to splitting these odd exponents up when you're simplifying these, okay? You can never have more than one under a radical when you're done, like I said. Alright? Alright, good luck, and see y'all in class.